variables. Okay. In general, this is the very simple block diagram. Okay. Now what we are doing here today? Today you observe that if we consider the whole system is in a one block like this. If we consider the whole control system, which is a closed loop, it may be a feedback, it may be a feed forward type of thing, cascade, and we will see adaptive and all these things. But if you observe, this is the system which is rationally arranged in the series in the closed loop, interconnected with each other to achieve common objective. Okay. So overall, when we are talking about overall transfer function, then by observing this particular block, the green bordered block, how many arrows are incoming and how many arrows are outgoing? My simple question is, which variables are coming from the outside and which variables are going from the system to surround? Please. Please. Please tell me. Just a minute.
Sir, you are on mute. Sir, you are on mute, sir.
हेलो. अच्छा, हाँ. हाँ, बोलिए बोलिए बोलिए. सॉरी, वो म्यूट हो गया था. हाँ. हाँ, बोलिए. See, two variables, if you observe, are the two arrows or the two particular incoming streams. That particular arrows represent that some variables are coming from the surrounding and it is affecting the system's variable. So it may be a disturbance, or it may be a set point. ठीक है, कैसे होता है? And which is under study is a control variable. My aim is to maintain the control variable. Okay. The achievement or the objective, it may be to suppress the output, that is the external disturbance, or to optimize it. Okay, likewise. So there are two variables or the two streams or these arrows nothing but the flow of information. Flow of information, it may be in different format. Okay, and which makes the affect the system's stability, possibly, maybe. So if you observe that set point and the disturbance, so we can compare this particular situation with our AC room. Say consider the AC room. AC room है, everything is closed, ठीक है? It is say well insulated है. So at steady state, whatever the temperature I have set on AC, say 25 degrees centigrade, so that time the sensor is showing 25 degrees centigrade at steady state I am talking about. At the same time, the temperature of the room will be 25. ठीक है? ठीक है? तो मुझे ये 25 चाहिए, तो ये सेंसर भी 25 सेंस कर रहा है. एग्री? तो एरर क्या रहेगा दैट टाइम? 0 रहेगा, क्योंकि मेरा सेट पॉइंट क्या है? 25 है. 25 minus 25 will be 0. So no control action is needed. ठीक है? बट मान लीजिए कि मैंने सेट पॉइंट चेंज कर दिया, 25 से मैं अपग्रेड कर रहा हूं इसको 26. But now at this particular situation, the process temperature is 25. It will sense by the sensor. Sensor observe this is the 25. The error of 1 will generate, and then the final control element will manipulate the compressor's flow. Okay, so there is a possibility that the set point may bring the disturbance in the system. Agree? Are you getting my point? Am I audible?
Yes, sir.
Okay. Another thing is that another way is, say the situation 1 25 25 25 steady state है. But what will happen with the disturbance? किसी ने आपके रूम का दरवाजा खोल दिया, खिड़की खोल दी गई, ठीक है? Because of that, what will happen? Heat will exchange with the surrounding. Some heat will go out if it is outer is hotter than that of the inside room. Okay, so the disturbance may cause the change in the profile. ठीक है? So that time मेरा तो यहाँ सेट पॉइंट 25 था, ठीक है? सेट पॉइंट क्या था मेरा? 25 था. सेट पॉइंट था 25. सेट पॉइंट था 25. ओके, बट डिस्टरबेंस के कारण क्या हो रहा है? ये मान लीजिए कि 27 हो गया because of, so here again it will say 27. So the error of 2 will go to the controller, and then the final control element will manipulate the resistance or the voltage to the compressor and so on. It will try. So there are either a set point or the disturbance, or simultaneously they may cause the change in the variable, system's variable. Which variable which we need to be controlled is a controlled variable. Are you getting my point? तो यहाँ दो situations तैयार होती है. If I will represent it by C, I will represent set point as R. I will represent load variable as U. Are you getting my point? Remember, R is a set point, load, okay, U is a load variable, and C is a control variable. Remember these terms. So there will be the two situations when the control system are generally faces. One is when the control variable change with respect to set point, and when the control variable change with respect to U, load variable. ये हमें इसका ट्रांसफर फंक्शन निकालना है. ये है ओवरऑल ट्रांसफर फंक्शन ब्लॉक डायग्राम. ये क्या है? ओवरऑल ट्रांसफर फंक्शन. इसको कहते हैं हम सर्वो मैकेनिज्म. ओके, और इसको कहते हैं हम रेगुलेटर मैकेनिज्म। आर यू गेटिंग माय पॉइंट? Remote control is a example of servo mechanism. Okay, are you getting my point? The study of the variation of control variable with set point change. The study of the variation of control variable. Study of variation of control variable. This one. Study of change in control variable with the set point with time for constant value of load variable. Here U is constant. Similarly, what is regulator mechanism? It is a study of change in control variable. Okay, it is the study of the variation of control variable with the load variable with time for constant set point. For constant set point. R constant है C by U में, U constant है C by R में. Are you getting my point? Is this okay? ठीक है. So this is the example for regulator is a voltage regulator and pressure regulator. We will discuss that. But now, if we consider whole control system, number of blocks, summation, controller, comparator, process, sensor, if we consider as a one block, that time two arrows are coming inside, that is the set point and disturbances, and one is going outside is a control variable. So how this control variable will behave if there is a change in either the set point or a disturbance or simultaneous change will be there, then how the C will behave. So this will give us the overall impact, this will give us the overall transfer functions. So हमें अब इन सभी को मैनेज करना है. जैसे हमने टू टैंक्स इन सीरीज रखा है, तो वैसे ये सीरीज में ही है, कंट्रोलर और फाइनल कंट्रोल एलिमेंट है ना, ये दोनों सीरीज में है. So similarly, we will identify the overall transfer function, and that overall transfer function, that the nature of the overall transfer will decide how that control variable will change based on the conditions, whether it is a servo or whether it is a regulator. ठीक है. एसी रूम में क्या होगा, अगर सिर्फ मैं सेट पॉइंट चेंज करता हूँ रिमोट से, कीपिंग ऑल विंडोज एंड डोर्स आर क्लोज्ड, that time we can say that C will change with respect to R. Okay, keeping U constant. ठीक है. दूसरा सिचुएशन ये है कि सेट पॉइंट 25 पे ही है, बट किसी ने दरवाजा खोल दिया है तो U चेंज हो रहा है. सो इट विल बी द C by U एंड कीपिंग R constant. तो रेगुलेटर आ गया, है ना. समझ गए? Is this clear? Now how to develop C by U and C by R things we will see. ठीक है. So let's start with we will identify what are the different nomenclatures we are using for the blocks. So as you know, the blocks, generally block diagrams, what we will represent in the block itself, they are nothing but the transfer functions, and the arrows nothing but the means of flow of information. It may be pneumatic or we will discuss that things, but on this we will nomenclature we will place over here is a nothing but the Laplace transform of the deviation variable of that particular variable. ठीक है. P, GC, GV, GP we are using. Remember this diagram in general because we will use number of times this diagram. GC is nothing but the transfer function of controller. GV is nothing but the transfer function of control valve. It is called as final control element क्योंकि valve generally use होता है. That's why GV. V represent this suffix represent what we call the valve. Okay. M is the manipulated variable. Plus sign represent that the summation will take place over here. Load variable and the manipulated variable combiningly will affect the controller control output, control variable values of control. GP represent that it is a transfer function of process. This P represent the suffix which represent the process. H is a measuring element. Okay. B is a measured variable. R is the set point. E is the error. P is the signal between the GC and GV. Okay. Is this okay? Okay. Now, how to develop? My aim is to develop GC by C by R. Okay. Before to move on that. So ये हम एक डायग्राम आइडेंटिफाई कर लेते हैं कि ये डायग्राम क्या है. ये डायग्राम we have already discussed that there was a continuous stir tank heater is there in which Q represent that that cursor is visible now, which I am moving over here on the Q. I am using PDF because that PDF that PPT is corrupted. I will recover it. So the is uh, Q is the particular the amount of heat, rate of flow of heat, which is going to be exchanged with this liquid. Okay. So it may be electric power or it may be steam. It is coming from this particular instrument. Okay, incoming stream is there, outgoing stream is there. Our aim is to keep the temperature of the outlet stream at this particular value T. Because of that, the sensor will sense the temperature, which is Tm. Comparison will take place, error will generate, and that error generated is nothing but going to the controller. Controller will take the corrective actions, and the corrective signals will send to the Q. Okay, and based on that things, the Q will get manipulated. Agree, and so the temperature will get adjusted. Okay, so this was the theme. Next is these are very physical equipments which we are representing over here. Now the same thing with the help of our block diagram systems. Okay, another thing is with the help of heat exchanger. Heat exchanger, this is the loop. Okay. तो my aim is the temperature of the outlet. ये shell and tube heat exchanger है. So the tube side fluid का temperature मुझे maintain करना है. So the tube side side I will put a temperature measuring element. It will sense here the temperature which it will sense. It will go to the transducer. Transducer is one of the component which will convert the heat into the electric current to the controller, because controller are sensing the electric signals only. So the controllers will sense that much electric current is there, and that electric current will be in the range of 4 to 20 milliampere. Okay, then controller will sense, then the calculations and all these things will take place. Controller again send the signals required for the corrective actions. It is in the terms of again the current. Okay, there is a converter will convert the electric current into pneumatic signals, and pneumatic signals will control the movement of the valve. It will close down or it will be open. Okay, and this is the mechanical motion. Mechanical motions will close the orifice of the pump. Okay, and it may cause the flow rate, it may get changed. Okay, So what is the concept behind is this? This is a very simple is thing. अगर ऐसे ही सिंपली बात करते हैं तो क्या करता है कि टेम्परेचर सेंस हो रहा है, टेम्परेचर सेंस हो रहा है, कंपैरिजन होगा, कंपैरिजन होने के बाद कंट्रोलर एक्शन लेगा, कंट्रोलर एक्शन will go to the control wall and control wall will manage the cooling water, and so the temperature will get adjusted. Okay, but what are these particular terms which we are introduced over here? The transducers and converters. The transducers and converters are nothing but the instruments or the equipments which converts the one form of signals into the other one. Okay, जैसे it is just a simple thing is that कि first law of thermodynamics क्या कहता है कि energy neither be created nor be destroyed. Okay, it can convert into from one form to another form. जैसे हम अगर लाइट लगाता हूँ मैं तो इलेक्ट्रिक करंट ल्यूमिनस में कन्वर्ट हो जाता है. तो likewise means one energy is converting to another one. फैन को मैं टर्न ऑन करता हूँ तो that electrical energy is converting into the electrical energy is converting into the mechanical energy, rotational energy, and rotational energy further departing as a flow of fluid. Flow of fluid means flow of air. Okay, so mass displacement will take place over there because of that energy. So this is nothing but the conversion of energy. Similarly, in this case also, the temperature that this thermocouple is sensing, that energy which is in the form of heat energy, or it may be a thermocouple hai, it may be the voltage. But the controller over here, remember this controller needs input in terms of electric current. So what transducer will convert? Transducer will convert this temperature, okay, into the required current. The proportionality will be there. That much proportions of the current will generate. That current is in the form of 4 to 20 milliampere. What does it mean? 4 to 20 milliampere इसका मतलब क्या है कि 4 to 20 milliampere का current it represent that either अगर कंट्रोलर को ओपन करना है, क्लोज करना है, टू एक्सट्रीम कंडीशंस रहेगी. either it will open at 20 milliampere, fully open हो जाएगा वॉल, और 4 पे क्या आएगा, फुल्ली क्लोज रहेगा. ये दो सिचुएशंस है. ठीक है, कोई सेंसर सेंस कर रहा है 4 मिली एम्पियर, कंट्रोलर सेंस कर रहा है 4 मिली एम्पियर. इसका मतलब क्या है? इसका मतलब है कि इसको फुल्ली क्लोज करना है. ठीक है, so there is two particular extreme conditions, fully open and fully closed. Which proportion that means how much that particular current it is receiving in the range of 4 to 20 milliamp. ठीक है, so similarly कन्वर्टर क्या कर रहा है? देखो ये कन्वर्टर क्या कर रहा है, कन्वर्टर करंट को मैकेनिकल एनर्जी में कन्वर्ट कर रहा है, which is in the pressure. Okay, so pressure line क्या कैरी करती है, हाउ मच प्रेशर इट इज कैरिंग 3 to 15 psi. Okay, 3 is associated with 4 and 15 is associated with 20 milliampere. It is aligned with this. अगर 4 है तो ये 3 रहेगा, ये 20 है तो ये 15 रहेगा. Okay, so the controller will sense this much amount of 3 or 15 or in between the 3 to 15. It will make partially open or partially closed based on the requirement. Are you getting my point? So transmission lines are maybe electrical or pneumatic lines. Okay, further we will see transmission. We call it as a transmission lines. Transmission lines, it is used for the flow of information. It may be pneumatic transmission lines or it may be electrical transmission lines. Pneumatic transmission lines carry the current in the range of 4 to 20 milliampere. Electrical transmission lines, while the pneumatic transmission lines carry the compressed air. It is in the 3 to 15 psi. What is a transducer and converter? It is a device which converts the energy from one form to another form. ठीक है, one form to another form. ये कैसे हो सकता है? जैसे आप पता है कि थर्मामीटर, मर्क्यूरी थर्मामीटर, what is that gain point in controller? किसका क्वेश्चन है ये? आशीष
Sir, in
नंदा.
the
Sir,
in the
what is
previous
that
slide.
gain point? Where it is? Previous slides.
Yes, sir. In that previous slide. Hello.
ये गेन क्या है? ये गेन, ये जो है ना, यहाँ मैंने बताया ना आपको, ये एडजस्ट करना है केसी, ys इज इक्वल टू केसी एक्सेस, ys बाय एक्सेस इज इक्वल टू केसी। यहाँ पीडीएफ में लिखा जाएगा क्या? मैं लेट मी देखता हूँ यार, पीडीएफ में नहीं लिखा जा रहा है, बट लेट मी डिस्कस ओवर हियर ऑन द वन नोट। यहाँ क्या होता है, हमारा पता है ना हमें, ys बाय एक्सेस इज इक्वल टू केसी फॉर पी कंट्रोलर। हमने डिराइव किया है पी कंट्रोलर के लिए, प्रोपोर्शनल कंट्रोलर के लिए इट वाज केसी।
यस सर।
तो ये एडजस्टेबल होता है। अगर जितना एडजस्ट करोगे, यानी फॉर स्मॉल केसी वाई स्मॉल रहेगा, फॉर लार्ज केसी वाई बड़ा रहेगा, यानी एम्पलीफाई करेगा। ठीक है, तो ये केसी आपको एडजस्ट करना है। दिस इज द नॉब ओवर देयर इन द कंट्रोलर। कंट्रोलर में नहीं, क्या हम स्पीड कंट्रोल कर रहे हैं इसकी, हम नहीं बोलते, हमें ऑप्टिमाइज करना है। टाइप दैट टाइप optimization is different term, but I am just telling you that कि how this is nothing but the adjustable one, वो adjustable रहता है। again, are you getting my point?
यस सर।
ठीक है, तो we will discuss that thing। तो gain है वो, gain is nothing but that KC, वो वहां कुछ ना कुछ तो रहता ही है, वो उसे रखना ही पड़ेगा आप। ठीक है, so हाँ, तो आर यू गेटिंग माय पॉइंट? न्यूमेटिक ट्रांसमिशन लाइंस हो सकती है या फिर इलेक्ट्रिकल ट्रांसमिशन लाइंस हो सकती है, बिकॉज वॉट एवर द इंफॉर्मेशन इज flowing from one point to another point, these particular two components not always there कि they work on the same principle, they may work on the different principles। जैसे कंट्रोल वॉल है, controller is working on the electronic devices, while the control wall it is nothing but a mechanical displacement equipment। आपके घर में जो नल होता है, घर में वॉल होता है, इट इज नथिंग बट द मैकेनिकल डिस्प्लेसमेंट इक्विपमेंट। आर यू गेटिंग माय पॉइंट? जैसे एनालॉग टू डिजिटल, डिजिटल टू एनालॉग। ओके, सो द ये ट्रांसमिशन लाइन, सो ट्रांसमिशन लाइंस इलेक्ट्रिकल करंट कैरी करती है 4 टू 20 मिली एम्पियर में। ठीक है, इसका मतलब क्या है 4 टू 20 मिली एम्पियर में, कि भाई अगर कुछ नहीं करना है तो 4 मिली एम्पियर करंट तो रहेगा ही इसमें। जैसे बायस होता था, हमने देखा ना प्रोपोर्शनल एक्शन में, इट वाज it was like bias when error is 0, q was a, q is equal to a आ गया था हमारा, है ना, ये bias था। तो दैट वे, हाँ ये वाला, ये देखो q is equal to qs is equal to a, दिस वन। तो एक कुछ ना कुछ वहां रहता ही है ऑलवेज। ये केसी है, हम केसी जो हम डिस्कस कर रहे थे, ये केसी हमें एडजस्ट कर सकते हैं, एंड बेस्ड ऑन दैट q कैन बी एडजस्टेड। ओके, सो वैसे न्यूमेटिक ट्रांसमिशन लाइन भी क्या कैरी करती है, तो इट इज अ प्रेशर, इट विल कैरी इन द रेंज ऑफ 3 to 15 psi, रिमेंबर। ठीक है, वी विल डिस्कस दैट थिंग। Another terminology we will use in the this block diagram is negative feedback system and positive feedback system। Okay, now remember that diagram again। The negative feedback system में error is defined as a set point minus measured one, सेट पॉइंट माइनस मेजर्ड। ठीक है, हमारा डायग्राम है ये वाला, हाँ ये है यू, कैपिटल यू, ये है सी, ठीक है, ये है आर, और ये है बी। ठीक है, सो निगेटिव फीडबैक में क्या होता है, एरर इज डिफाइंड एज आर माइनस बी, दिस इज आर। ठीक है, और पॉजिटिव फीडबैक में क्या होता है, एरर इज इक्वल टू आर प्लस बी। ठीक है, these are the some terms we can use. ठीक है, these terms. रिमेंबर स्टूडेंट्स, नेगेटिव फीडबैक में एरर का अगर किसी चीज का हम डिफरेंस लेते हैं तो वो ऑलवेज इट रिप्रेजेंट दैट कि एरर कम करना चाहते हैं, बट पॉजिटिव कर रहे हैं, एंड दैट मींस इफ यू आर एडिंग द डिस्टर्बेंसेस दैट मींस यू आर इंक्रीजिंग द एरर. आर यू गेटिंग माय पॉइंट? एरर आपको कम करना है या ज्यादा करना है, वेरी फर्स्ट थिंग. तो ये जो पॉजिटिव फीडबैक सिस्टम है ना, ये एक्सीडेंटली आती है. वी नेवर प्लान इट फॉर द आर प्लस बी कंट्रोल सिस्टम. वी नेवर प्लान फॉर आर प्लस बी सिचुएशंस. ये सब एक्सीडेंट्स होते हैं, जबकि एरर बढ़ते ही जाता है. जो मेजर के साथ बढ़ते जाएगा तो मोर एंड मोर कंट्रोल एक्शंस आर नीडेड, एंड समटाइम्स इट कम्स टू द सैचुरेशन में डिफरेंट एक्सीडेंट्स में ऑकर बिकॉज ऑफ दैट. आर यू गेटिंग माय पॉइंट? समझा? ये समझा गया. बट दीज आर द सम टर्म्स व्हिच आर नीडेड टू बी, यू शुड नो कि भाई नेगेटिव फीडबैक क्या होता है. इट्स द डिफरेंस बिटवीन द सेट पॉइंट एंड द मेजर्ड वेरिएबल. बी इज अ मेजर्ड वेरिएबल. Okay, and positive feedback is something we are adding the set point with the measured variable, so always it will go rise, it will rise, it will always error will increase. And error increase होना है ना, क्या है, सिस्टम अनस्टेबल है. सबसे पहली बात है ना, हमें एरर बढ़ने नहीं देना है, कम करना है. ठीक है, तो इस सिचुएशन में cause of the some accidents for the it's 12:38 time है. So there are the two situations which we have discussed earlier. The control system always work on that. One is the servo mechanism in which rate of change of load variable is constant with respect to time, and we represent it by C by R. And dr by dt is nothing but the set point is not changing with respect to time. It is constant. So first derivative of dr is r is constant, and we represent it as a c by u. Already we have discussed this. Okay, so first is formula is called as a servo mechanism, and latter is called as a regulator mechanism. Agree? Agree? Okay. यहां तक कोई दिक्कत है आपको? एनी क्यूरी? नहीं? Shall we move? Okay. Further? हाँ. Now what we will, our aim is to develop, ये क्वेश्चन पूछा जा सकता है, develop overall transfer function for change in set point for negative feedback system. क्वेश्चन क्या हो सकता है? This is the question, nothing but that. Develop overall transfer function for change in set point. For change in set point. ठीक है? Is this visible? Overall transfer function. ये क्वेश्चन है. Okay. Overall transfer function for change in set point for negative feedback system or servo mechanism control. Is this visible?
Yes, sir.
हाँ, तो देखिए ये क्वेश्चन है हमारा. overall transfer function for change in set point for negative. अब I'm not again, let me redraw it, but in short, ये मेरा सिंपल r है प्लस ये माइनस रहेगा, सॉरी, ये है मेरा gc gv, this is u is coming down, gc gv gp. Is this visible? Negative. Is this visible? दिख रहा है ना?
यस सर।
ठीक है, तो ये मेरा एक ब्लॉक डायग्राम है जो मैंने अभी ड्रॉ किया है, नॉट गुड बट जस्ट फॉर द कन्वीनियंस। ये मेरा ब्लॉक डायग्राम है, and what is my aim? My aim of this is overall transfer function, overall transfer function, okay, ये c है, ये b रहेगा, ये r है। the overall transfer function was change in the set point, change in the set point, set point क्या रिप्रेजेंट कर रहा है? set point का क्या वेरिएबल है? what is the nomenclature of set point? which particular alphabet we are using for set point? Capital R we are using, ठीक है। तो the transfer function for change in the set point for negative feedback, तो overall change in the set point, और किसको कंट्रोल करना है? हमें C को कंट्रोल करना है, तो ये हो गया हमारा एम। एंड फॉर द नेगेटिव फीडबैक सिस्टम, नेगेटिव फीडबैक सिस्टम मींस क्या है? R माइनस P, नेगेटिव फीडबैक सिस्टम, तो इसको ही हम क्या कहते हैं? सर्वो। अरे चलो ठीक है, फाइन। अब मुझे ये करना है, ये बनाना है, ठीक है। तो हम कैसे करेंगे? हाउ वी विल स्टार्ट दिस थिंग? सी हियर, वी विल गो वन बाय वन, ठीक है। तो ये कैसे आ गया? देखो, जीसीजीवी, जीसीजीवी को मैंने मल्टीप्लाई कर दिया, मुझे पता है कि दे आर इन सीरीज, बिकॉज आई नो दैट, वेरी सिंपल, आउटपुट अपॉन इनपुट है, मुझे पता है, ठीक है। जीसीजीवी को मैं एक ब्लॉक में लिख सकता हूँ, बिकॉज आई नो दैट, इज दिस विजिबल? ये मेरा एरर है, this is the m is the manipulated, and say it is any f, ये e है, ये f है, और ये m है। तो gc का ट्रांसफर फंक्शन क्या है? व्हाट इज द gc का ट्रांसफर फंक्शन क्या रहेगा? आउटपुट अपॉन इनपुट, f is output to gc and e is the input to gc, okay। what is the output of gv? m upon f, so it will, ff will get cancelled, m by e, so I can represent the single block of these two as input is error, output is m. Agree? Agree, students? ठीक है। Similarly, this u is constant. This u is constant. It's constant. Its deviation will be 0. लोड वेरिएबल में चेंज नहीं हो रहा है, बिकॉज वी आर डिस्कसिंग c by r. We are considering u is 0. U is 0. U, capital U is deviation variable. When deviation variable is 0, represent that that variable is there, but it is not changing with respect to time. Are you getting my point? Are you getting my point? Please respond. ठीक है? So that time GP also, see here GP we can represent like this because U में कुछ changes नहीं आ रहे, so we will simply neglect it. U is constant, not zero. Its deviation variable is zero. ठीक है? And in this particular block diagram we use the deviation variables. So as deviation variable is zero, we will neglect that it is not affecting anyhow to the C. Therefore, GC, GV, GP will come into the series. Similarly, we can again rewrite it as a GC, GV, GP as a one block. What will the output over here? It will be the C. Incoming is R. Again, is the comparator will be there. It is R plus negative feedback होने के कारण यहाँ ये negative sign रहेगा and it will be like this. इसको हम कहते हैं, इस मेथड को कहते हैं reducing block diagram method. इसको number of blocks are there, shrinking into the single one. अच्छा, reduction of block diagram. It is called as reduction of block diagram. इसको क्या कहते हैं? Reduction of block diagram. अब देखिए ये तीनों सीरीज में थे इसलिए it is okay. GC, GV, GP. अब now H is in a parallel with this. Okay, I would like to develop C by R. I would like to develop C by R. For that purpose, what are the different variables I have? So let's see, I have error is equal to R minus B. And what is the H? I will define H is equal to B by C. B by C. R. B is equal to HC. I will substitute this into error. Error is equal to R minus HC. R minus HC. R minus HC. ठीक है? And further GC, GV, GP क्या दे रहा है मुझे? ये देखो, ये इक्वेशन ये क्या दे रहा है मुझे? GC, GV, GP is equal to C by E दे रहा है. I can replace this E by this R minus HC. मैंने रिप्लेस किया, इन टर्म्स ऑफ R में ले आया मैं इसको. Are you getting my point? Now अब देखिए इसमें सारे ट्रांसफर फंक्शन है GC, GV, GP, H और कौन से वेरिएबल्स है यहाँ? सिर्फ C और R. सारे बाकी के वेरिएबल्स हमने रिप्लेस कर दिए. Okay, so rearrange this expression, you will come to know that GS overall is equal to C by R is equal to GC, GV, GP by 1 plus GC, GV, GPH. You try it your page on your page right now. Just use these two variables, two left hand side and right hand side terms. You will observe that you will come to know that our aim is C by R identify करना है. So it will come in this fashion. देखिए ट्राई कीजिए, आ रहा है या नहीं आ रहा है? Separate the variables and bring it into the form of C by R. ये लाप्लास है, याद रखिएगा. Capital I am using, but it is a Laplace because transfer function itself the transfer derivation of the variables. आ रहा है ये? Okay. So remember one thing. Remember one thing. So we can represent it as a, now it is shrink into the one. So this is called as the reduction of block diagram. GCGV GPH. ठीक है, लड़के 10 मिनट पहले ही क्लास छोड़ जाते हैं। तो ये हो गया सिंगल ब्लॉक, हम रिप्रेजेंट कर सकते हैं इस तरीके से, GCGV GP by 1 plus GCGV GPH। ठीक है, अब ये क्या है, दिस इज नथिंग बट लेट मी टेल यू कि देयर इज अ वन वेरी स्टैंडर्ड फॉर्मेट इट विल अचीव। तो ये है, देखो ये हमारा सेकंड स्टेप है। पीडीएफ दिख रही है आपको? ठीक है, ये GCGV GP सीरीज में आ गए हैं, मल्टीप्लिकेशन में एच पैरेलल में है, एंड ओवरऑल यू विल गेट GCGV GP by 1 plus GCGV GPH। अब ये फॉर्मेट क्या है, इसको कहते हैं हम, देखिए, if would you like to develop C by R, then you can directly use this formula, product of all the transfer functions between C and R divided by 1 plus product of all the transfer functions in the entire control, in the entire control। ठीक है, कंट्रोल लूप अब ऐड कीजिए आप, GCGV GP, फिर कंट्रोल वेरिएबल C होता है, फिर लूप होता है डाउन साइड, देन देयर इज अ सेंसर, इट विल गो बैक टू द कंपैरेटर विल गिव अस द एरर E, and then the signals again GCGV GP, in between GP and there is a control wall, there is a downward arrow called load variable is there। Okay, you remember this diagram always, keep in your mind। So overall C by R कैसे डिफाइन करते हैं, प्रोडक्ट ऑफ ऑल द ट्रांसफर फंक्शंस बिटवीन C एंड R। C कहाँ है, एक एक्सट्रीम कंडीशन पे है, ठीक है, C कहाँ है, देखो C कहाँ है, ये है C। ओके, इट इज द प्रोडक्ट ऑफ ऑल द ट्रांसफर फंक्शन बिटवीन C एंड R। तो GCGV GP divided by 1 plus product of all the transfer functions means GCGV GP plus H into H। Agree? Same thing is here। ठीक है, समझ में आ रहा है ये? Everybody please reply। Okay, so the homework for you is develop the overall transfer function for change in load variable with negative feedback। ऐसे ही आपको बनाना है। तो लेट मी टेल यू द फाइनल फॉर्मेट ऑफ C by U इज, हमने C by R देखा है अभी पहले ये, ठीक है, रिमेंबर इसमें क्या है, न्यूमरेटर में फंक्शन बिटवीन C by R डिवाइडेड बाय 1 प्लस प्रोडक्ट ऑफ ऑल द ट्रांसफर फंक्शन। तो C by U में क्या होगा, व्हाट इज द डिफरेंस, इट इज द प्रोडक्ट ऑफ ऑल द ट्रांसफर फंक्शंस बिटवीन C एंड U divided by, denominator same है, denominator is same, but in the numerator product of all the transfer functions between C and U in place of C by R। देखिए ये डायग्राम देखिए, GP by 1 plus GCGV GPH, न्यूमरेटर में सिर्फ GP है, GP is in between only C and U, C and U के बीच में क्या है, GP है। एग्री? एग्री स्टूडेंट्स?
यस सर।
ठीक है, तो ये आपको डिराइव करना है। ये एक हो गया नेगेटिव फीडबैक। अब दो कंडीशंस और रहेगी C by और C by U के लिए, अगर E is equal to R plus B है, that is a positive feedback, go for that also। तो that time also you observe that the denominator में सिर्फ नेगेटिव साइन आएगा, न्यूमरेटर सेम रहेगा, ठीक है। So this is the example which this is the solved example from Kafner। Determine the transfer function, let me read you। Determine the transfer function C by R, C by U 1 and B by U 2 for the system shown in figure। Also determine the expression for C in terms of R and U, one for the situations when both set point change and load change occur simultaneously, as I have told you. Okay, there is a possibility that the simultaneous change may occur and which may cause the variable change. Okay, so this is the diagram actually. If you reduce it C by R, you will get GC, G1, G2, G3 upon G1 plus G. What is G? G is nothing but the product of all the transfer function entire loop. It includes H also. So C by R, C by U1 and B by U2 is there. So answers are there. You go, you try at home this particular practice. This is also one of the solved example. तो ये cascade कहते हैं. इसको meaning means the loop within different. Okay. So other loop. Okay. Loop within other loop. So there is a possibility इसका output इसके लिए जाता है. ठीक है. Likewise. So पहले internal loop को आपको solve करना है first and then go for the above. Next primary loop is this inner loop, then the secondary loop is outer loop. So see here, inner loop has been solved. It is observed like this is, and then overall has been solved like this. C by R. Agree? Agree? So we will stop here. So block diagram reduction is covered today.